Alrighty, directed algebra. So we are going to work on a couple things and really remind ourselves some of the things that we did last semester. And all of the problems that we are going to do today are going to be directly related to chapter 6, which we're going to start tomorrow. So when we work through these problems, make sure that you are hopefully going back through old notes, which we hopefully did not burn over break, as well as going through and reading the helpful hints that I provide at the start of each quote-unquote station. So what I have handed out to you, or your sub has handed out to you, is this white paper that says Semester 1 Recap Stations. But then on Google Classroom, you'll find the Semester 1 Recap Stations themselves. So we go through each of these, and what we're going to do is we are going to do one problem from each station, which is going to leave you with, 5 stations. That'll leave you with 10 problems left to do in class, and then you'll have the worksheet related to these sorts of problems as well for homework. So make sure that you've got this document pulled up, because you are going to need this once we are no longer working through them together, and that's just on the message, stream, whatever that I put on Google Classroom. So that's where you'll find these stations. But then that stations worksheet, that white piece of paper, is going to be handed out to you if it has not been already. So without further ado, we are going to start with problem number 1D. So that means that it's station number 1 and problem D. So before we start, let's see what station 1 is all about. So station 1 is all about solving linear equations, which we did in chapter 2. When we solve linear equations, we need to isolate the variable by using inverse operations. So remember, inverse operations. Well, what undoes multiplication? Division. What undoes subtraction? Addition, right? And so our general rules are to use the distributive property to remove all parentheses, right? If you need to distribute something, you do that first. You combine like terms on the same side of the equation, and then collect all of your variables to one side, everything without variables to the other. Then you solve for the variable like normal, and you check your answer. So, for example, we are doing station 1 and problem number D. So we've got negative 0.4 times the quantity, right? Quantity means parentheses, of 5x plus 25 equals negative 12. So let's start by writing down the problem. We've got negative 0.4 times 5x plus 25 equals negative 12. So I would write this along with me, and then you can pause it as you need to in order to make sure you've got the right answers written down. So if we have parentheses, we do what first? We distribute. So we'll take negative 0.4 and multiply it by the 5x and the 25. So negative 0.4 times 5x is going to give us a negative 2x. And negative 0.4 times 25 is going to be negative 10. That equals negative 12. Well, from here, we solve like normal. So we've only got one x. We have no combining like terms to do. But what we can do is we can move that 10. The 10 is attached to my variable using subtraction. To undo subtraction, we use addition. So we get to add 10 to both sides of our equation. Make sure you do it once left of the equal sign and once right of it. So we have negative 2x equals negative 12 plus 10. Oh boy, same sign, add and keep? No. Different sign, subtract. 12 minus 10, we get 2. Take the sign of the bigger number, negative 2. Negative 2x equals negative 2. Well, the last number attached to x is that negative 2. It's attached by multiplication, and to undo multiplication, I use division. So I divide both sides by negative 2, so I get x equals positive 1. There is our final answer, but just to be safe, we are going to check our work. So we will plug it back in for x. We pull a GLADE and plug it in. Negative 0.4 times 5 times 1 plus 25 is supposed to equal negative 12. Well, 5 times 1 is just 5. 5 plus 25 is 30. Is negative 0.4 times 30 going to equal negative 12? Well, one way to find out, plug it into your calculator. Okay, and hopefully you have checked that. First of all, we've got a negative times a positive, so that better equal a negative. That checks out. And you'll find that that does, in fact, give us negative 12. So our final example, or excuse me, our final answer for problem number, well, station number 1, problem D, is 1. Okay, now we are going to move on to station number 2, but remember you need to complete all of the station number 1 problems before the day is done, so don't forget those. So station number 2, we're going to do problem B. Well, what is station 2 all about? Station 2 is all about rewriting equations and formulas, so rearranging things, moving things around. When equations have multiple variables, so x and y, for example, they can be rewritten so one variable is a function of the others, aka we can solve for whatever variable we want. If we're ever asked to write a function so that y is a function of x, we just want to solve for y. That's all we're really asked to do. And then if you have the opportunity, remember to, what I call, distribute the divide. So if you're ever dividing by something and you've got multiple terms on the other side, make sure you take every single term and divide by whatever it is you're dividing by. So here are our problems. Our instructions are to rewrite the following equation so y is a function of x. There it is. Rearrange it so that we solve for y. Then what we'll do is we'll identify the slope and y-intercept of each, and we'll talk about that in a little bit. So we are doing to B, which is 3x minus 4y equals 4. 3x minus 4y equals 4. And we are asked to rewrite it so y is a function of x, aka we want to solve for y. Well, if our goal is to solve for y, the 4 is super strongly attached to it, so we can't get rid of that yet. But what we can get rid of is that 3x. Our 3x is positive. It's being added to that negative 4y. So what we will do is the opposite of that. We will subtract it. Whoopsies. And we want to make sure we subtract once on the left and once on the right of that equal sign. We're left with negative 4y on the left, and that equals, let's put that x term first, negative 3x plus 4. Why not? Now from here, we have one more number attached to y. It's negative 4. It's attached by multiplication, so to undo it, I need to use division. And this is where I say distribute the divide. So every single piece needs to be divided by negative 4, and we get y equals, well, negative 3x over negative 4, just work with those numbers. Negative 3 over negative 4, well, it's a negative over a negative, so it's going to be positive, and we'll just call it 3/4. And we stick the x after it. And then 4 divided by negative 4 is going to be a negative 1. So we have rewritten it so y is a function of x. Now, this is in slope-intercept form. Y equals mx plus b, but you didn't even know it. So your m, your slope, is going to be that number in front of x, which is 3/4. Your b is that, oopsies, can't see that, is your y-intercept, and it's going to be whatever piece comes after the x. So your y-intercept is a negative 1.